the contact. So what should be the find the minimum value of mass A so that block B leaves contact. I think we did same problem without this. Can you remember? Without this spring, upper spring, we discussed this problem. Now I'm bringing multiple springs here. Any constraint equation, like whenever we get a situation like this, no, we do go for constraint. No? Let the displacement of block be x. Let the displacement of this spring be x1. Let this be x2. From constraint equation, how the displacement of blocks are related. X is equal to, should be x1. Assume that the spring is not there. I'll call spring 2 spring 1. Assume that spring 2 is not there. When spring 2 is not there, what is the displacement of block? Should be equal to elongation of spring 1, x equal to x1. Plus, assume that now this spring is not there. If this spring 2 elongates by 1 meter, how much the ball A or the block A will move down? Will move by 2 meter. So therefore, what is x? X equal to 2x2. There's a one basic constraint equation what we have. Then let's equate on the pulley, what are the forces that will be acting. On the pulley, the forces acting are what are the forces that will be acting here? 2k or kx2. This should be kx1. Let the elongation of the spring be x1. This is elongation be x2. So what is the constraint equation? Net force on the pulley. Pulley is massless. So kx2 should be equal to 2kx1. So x2 is equal to 2x1. But what was our question? Our question is what? Find the minimum value of mass of A so that block B lose contact. When the block B will lose contact. So for block B to lose contact, what should be the spring? Spring should be elongated, no? Spring 1 should be elongated, and the spring force should be such that already we have discussed, just I introduced one more spring, that's all. What should be the state of this? It should be elongated. So how much of spring force? Kx1 spring force will act here. That kx1 should be able to lift mbg. So when the block B loses contact, kx1 equal to mbg. For the spring 1 to get elongated by x1, tell me how much block A should move. Shall I say, will it move by, should undergo displacement by x1 or should undergo displacement by x? It should undergo displacement by how much? By x. I think you'll go wrong if you write x1 because of the spring is there. And what is the state of this? Instantaneous rest. Shall I write IR and it is released from rest? Shall we apply conservation of mechanical energy? Shall we apply? So the decrease in potential energy of block A, MAGX, should be equal to increase in elastic potential energy of the springs. Why there is no kinetic energy? You look at the block B, it was at rest and about to lose contact, it's at rest, and block A is released from rest, and it will be at extreme point when block B is raising. Any reason for that? Because I asked minimum. So what is the state of the block A? Will be at extreme point. At extreme point, what happens? The block should be at rest. And you should not equate forces at extreme point. You should not equate forces. So substitute the value of x2 here. So this will be MAG x equal to k1 x square, k by 2, x2 is 2x1 whole square. This will be 5k x1 by 2. So what is x1 value? So kx1. So in place of x1, what happened? You can write it mbg by k. Substitute that. But we don't know x1 in terms of x should be brought, no? So let me take help of this equation. X1, this is x2 is equal to 2x1, no? So therefore x1 equal to x by 5. So mag x is equal to 5 by 2, 1 kx1, write it as mbg. Other x1, you write it as x by 5. ma is equal to how much? mb by 2. Check calculation once. So there can be multiple springs also. A problem's numericals will do